We are now on to lecture 3, which you'll find on page 7 of the outline, the lecture outline. Recall we looked at linear functions, uh, which you did at school. We looked at what are the uses of linear functions. We looked at the total cost function, the revenue function, and the profit function, those concepts, and also break-even point in the previous lecture. So now we're looking at applications. A shirt producer has a fixed monthly cost of $3,600. So this here is your fixed cost. Right? If each shirt has a cost of $3 and sells for $12, find the break-even point. Find the break-even point. So your solution. Let's introduce the variables. Let x equal to the number of shirts produced and sold. Right, so your cost function, capital C as a function of x, right, is going to be, we know that each shirt costs $3, so it's going to be 3x, right? That's your variable cost plus your fixed cost, which is 3,600. Now your revenue, right? The revenue function, capital R of x. So capital R as a function of x, right? This is what is going to be realized when the shirts are sold, and each shirt is sold for $12. So capital R of x will be 12x. We want to find the break-even point at the break-even point. We know that the revenue function is equal to the total cost function. So this implies now that 12x is equal to 3x plus 3,600. Right? We call that equation 1 and this one 2. So this is from equation 1 and equation 2. Right, and you can solve this. Solve for x, you end up with x is equal to 400. So that's the number of units that must be produced. Right, so the revenue when 400 units are produced is going to be 12 times 400, and this gives us 4,800. So your break even point is given by the coordinates 400 and 4,800. So if you're interpreting this, it's at 400 units, the break even revenue is $4,800. So in other words, there's no profit or loss. Okay, that's the interpretation. We now move on to page 8, and there's a new concept. The concept is market equilibrium. This occurs when the quantity produced is equal to the quantity demanded. You must study examples 6 and 7. It's on page 46 onwards of the text. Right, the example that we're going to discuss, my advice to you would be to stop the video, try the example, and then you can continue. The maker of a plastic container has determined that the demand for its product is 400 units. If the unit price is $3 and the demand is 900 units, if the unit price is $2.50, right? So it's $2.5. The manufacturer will not supply any containers for less than 1 rand. Sorry, $1. But for each 0.3 increase in unit price above the $1, the manufacturer will market an additional 200 units. Both the supply and demand functions are linear. That's the assumption, right? Let P be the price in dollars and X be units of 100. Now be careful over here. X is in units of 100, right? And what we need to do is to find the demand function and the supply function. So the demand function, right? That's going to come from the part that's underlined in green. So basically, it's from the first sentence there, right? So the solution, A, the demand function, right? Your X, the units, it's in units of 100, right? The units that are sold. And your small p is the price. It depends on the units sold. So if we form that ordered pair, the ordered pairs that we have from the first sentence, we know that when 400 units, the demand for the product is 400 units if the unit price is $3, right? So since X is in units of 100, it's going to be 4, and the price, right, is 3. That's the output price. And we know that there will be 900 units of the product if the unit price is $2.5. So 900 units. So X is going to be 9 in this case, since it's in units of 100. And the price is going to be 2.5. So we're dealing with a linear function, the gradient m, right? Working with the coordinates of these 2 points above. It's 3 minus 2.5, all divided by the corresponding change in the input. It's 4 minus 9. This gives us 0.5 over -5. So this gives us -0.1. Therefore, the output variable P will equal to -0.1 of X plus some constant. Right, we can now, to find what the constant K is, we can substitute any of the coordinates. So if I take the first coordinate, substituting for 3 gives 3 is equal to -0.1 multiplied by 4 plus K. So therefore K is equal to 3.4. Therefore, your demand function P is given by P is equal to -0.1 X plus 3.4. Now for the supply function, the second part of the question, the supply function, we work with the parts in blue. The manufacturer will not supply any containers for less than $1, but for each $0.3 increase in unit price above $1, the manufacturer will market an additional 200 units. So working with that part, with that information for the supply function, right? The input is X and the output is P. We know that no units will be supplied when the price is $1 and even below $1, right? And we know that 200 units will be supplied. The input will have to be 2 since it's in units of 100. Right? So an additional 200 units will be supplied for each $0.3 above the unit price of $1. So the unit price here is going to be 1.3. Right? What you need to do is to work out what the supply function is. I'm not going to work it out over here. You can stop the video, work it out, and then refer to the lecture outline. The next part of the question, C, the equilibrium price and quantity. The solution. For market equilibrium, your supply must equal to the demand. Right, so you can work with your supply and demand functions, uh, which you'll find in under A and B. Work with that to answer this part of the question and stop the video. And then for your solution, after you did the working, you can refer to the lecture outline. We will stop over here.